came across a fantastic essay in Bloomberg. Chaos scientist finds hidden financial risks that regulators miss. Oxford professor Doyne farmer, quite a character going from the photograph. Oxford University professor Doyne Farmer traces his research exposing risks in the financial system to the roulette wheels of Las Vegas. In the 1970s, Farmer and two fellow physics students at the University of California at Santa Cruz built a computer small enough to hide in a shoe that helped them predict roughly where roulette balls would land. At casinos in Vegas, they communicated with toe control switches and transmitters, also in their shoes, about what bets to make. The gadget was legal, but they feared their winnings, about a 20% return on their wagers, would lead to trouble, so they quit after a couple of years. We were nervous about getting our kneecaps broken. Today, in a more bucolic setting, the Institute for New Economic Thinking at the Oxford Martin School, Farmer is drawing on decades of complexity research that began with roulette. After winning acclaim as a pioneer of chaos theory, which helps explain the unpredictability of complex systems such as the weather, he jumped into the markets, co-founding one of the early quantitative investment firms in the 1990s. Agent-based models used in fields from biology to sociology are bottom-up, simulating the messy interactions of hundreds and even millions of agents, human cells, or attitudes or financial firms to explain the behavior of a complex system. The non-linear interplay can produce unexpected phenomena such as economic busts and booms, providing insights into the causes of events and the best responses. Epidemiologists have successfully deployed the models for years to test strategies to control everything from obesity to the spread of infectious diseases, including the flu. Today, central banks mostly stress test financial firms individually, but agent-based models are giving regulators a better read by accounting for the system-wide impact of shocks. In the simulations, a shock to a single firm cascades through the network of banks and asset managers, creating feedback loops that significantly amplify the initial losses. It's the kind of contagion that a decade ago spread from the US subprime mortgage market through lenders, money managers, and insurers, creating a liquidity crisis that doomed Lehman Brothers and infected the global economy. The banks are highly interconnected and highly leveraged. We now know from Lehman that if something happens to one bank, it can be devastating to the entire economy. Reveals that financial losses from shocks could be 3 times greater compared with the traditional stress test, and that current capital buffers may be too small. He leapt into uncharted territory in the 1970s when he was a physics graduate student specializing in cosmology at UC Santa Cruz. He switched his focus to chaos and complex systems, a subject so new that there were no professors who could teach it. The scientists showed that the volatility is generated from within, caused by chaos, in which a small disturbance in the initial conditions of a complex system is amplified exponentially. That's why the weather is so hard to predict, the butterfly effect, as it were. In 1981, Farmer went to the Center for Nonlinear Studies at Los Alamos National Laboratory, where freewheeling research was the norm. In 1991, Farmer started Prediction Co. in Santa Fe, New Mexico with two physicist friends, Norman Packard and James McGill. After about 5 years, predictions automated statistical arbitrage strategy was earning risk-adjusted returns about 5 times the S&P 500s. He says he had several conversations with legendary hedge fund investor George Soros. When Soros's Institute for New Economic Thinking formed a partnership with Oxford in 2012, the university hired Farmer to run its complexity economics program. Complexity economists, while few in number, have a shared ambition to knock holes in a cornerstone of DSGE models, rational expectations, the idea that everyone in the economy understands each other's decisions and are mutually compatible in their pursuit of their self-interest. People don't obey rules as reliably as atoms do. In his stress test model of the European financial system, for instance, he had to make assumptions about what assets bankers might dump after their firms suffered shocks. They will likely sell the most liquid assets because they will lose less money. Agent-based models also suffer from the black box problem. The inner workings are so complex, with thousands of agents running in different directions, that it can be difficult to pinpoint the main drivers of a model's finding. This is a photograph of the gentleman by Carlotta Cardano for Bloomberg Markets.